Okay, welcome to today's webinar in our series on the future of AI in education and training. I'm Lewis Johnson, the overall host of this series. In this series of webinars, we are exploring the potential of AI to have impact on education and training. And we see that it has impact on a variety of different industries, but we see a big potential impact to have a change in education. What we're going to be talking today about is methodology for developing learning environments that take advantage of the potential of AI and big data. We call it data-driven development, or D3. As I go through this presentation, feel free to enter questions into the chat window, and then at the end, I'll go review the questions and answer any other questions you might have at that time. So this is a little background about me. I have been involved in AI in education for a number of years, initially in research at the University of Southern California, and then founded my own company that uses AI-driven learning approaches to provide effective learning to learners around the world. So the background of this talk is emerging trend that we see of educational enterprises globalizing. We're starting to see educational institutions that are expanding globally. For example, a client of ours at Alelo, Laureate Education, they are a network of higher education institutions around the world. They have 1 million students worldwide. This is an example of some of the large-scale computer-based, technology-based education enterprises which are emerging. And in general, we're seeing a lot of movement of learning to go online and online programs that are seeking to scale. For example, VIP Kid is an example of an online learning system that's being used in China. Basically provides tutoring to Chinese students from English teachers in North America. And they recently raised $500 million to expand globally. So we're seeing organizations that are moving online and are seeking to scale. And these systems, these organizations are relying on cloud-based technologies, and these cloud-based systems, these cloud-based learning systems have the opportunity to collect data from learners as they're interacting with them. And so we're now seeing learner data being collected in unprecedented amounts. And so the question that we're going to be talking about today is, what opportunities does this big data afford to AI in education? What I'm going to argue is that with this available, change the way we go about developing instructional materials in order to best take advantage of this data. Basically, we need an approach to instructional design that is more data-driven than has been in the case in the past. So to make this point, let me contrast with the way that instructional design has conventionally been done in the past, which is the conventional method called AIED, which is an acronym, stands for analysis, design, develop, implement, and evaluate. So in this approach, this waterfall-based approach, there really isn't much opportunity to collect data from learners using the instructional materials until the final phase, the evaluation phase. So there's not much opportunity to exploit data during the design and development process. In fact, in our experience, and I don't think it's unusual, is that by the time learning systems are deployed, people are too busy teaching that they don't really take any time to collect any data to perform an evaluation. So often there really is a lack of learner data, period. But we know that AI, machine learning, lives off of data. So we need a way in which we can take advantage of that data through the development process. So this is the basis for the methodology that, that we've been developing and recently have been employing at Alelo, called data-driven development, or D3. And so the idea here is to start with learner data from the very beginning. Before you, in the early phases when you're just designing a system, collect learner data, mine that data to understand what are the actual learner behaviors that need to be designed for. What are the learner problems that need to be overcome? Then as that data is mined, then that can be used to train models using machine learning that can be incorporated into the system, to update the product, typically an online product that learners can use. And then you deploy that product, and then as it's deployed and as people are using it, it's collecting more data. And then you mine that data, and then you retrain the models. So what you end up with is a highly iterative development process that utilizes learner data from the get-go. And so it's, iteration in instructional design is often stressed as an important attribute. But I'm arguing here that the cloud-based learning systems have the opportunity to iterate at a much faster rate and take advantage of data to a degree that has not been possible in the past. So what are some of the key characteristics of D3? And we'll go through these over the course of this webinar. So first of all, learner data is being collected both before and during deployment of the system. So basically, learner data collection never stops. The design of the system is informed by actual learner behavior as opposed to what the designers imagine learner behavior might be. The highly iterative approach has a couple of advantages. It makes it possible both to test the system currently being deployed, as well as alternative versions, alternative models, alternative algorithms that can be tested in background on the same learner data. And then as data becomes available, using cloud-based machine learning systems is now possible to retrain and redeploy models very rapidly, which also accelerates the iteration. Also, in this approach, evaluation and research becomes highly iterative. What we find is that evaluation studies tend to look at snapshots of the current system and derive results and then allow the system to proceed. Because these systems are rapidly evolving, it has to be done in a snapshot fashion. I recently gave a presentation at Stanford about this approach, and one of the questions that came up is, well, how do you get a PhD in educational research with this kind of approach if you're going to be doing a very quick study as opposed to a lengthy PhD-sized study? So basically the answer I get to that is, well, what you can do then is you could organize a study as a series of snapshot evaluations that can actually both test hypotheses and then test solutions to problems that are found in the earlier iteration. So overall, the outcome or the result of this approach is rapid innovation and rapid system improvement. So it really, I think, helps to energize the development of instructional systems in a very interesting way. So what we're talking about here are systems that rely upon AI to support education. So AI tends to be used in a number of different ways. I'll give you sort of a quick view of what I see as sort of the important characteristics of AI in the context of educational systems or AIED systems. So one aspect of an intelligent system is the ability to understand, to be able to collect, analyze, to interpret data. So this is very important for instructional systems to be able to interpret what learners are doing and then be able to respond. The system needs to have a decision-making capability. Instead of requiring people to follow say, a strict curriculum sequence, we want instruction that is personalized, that is adaptive, that is just, so where the system is deciding from moment to moment what would be an appropriate topic or activity to work on next. And then finally, learning is a hallmark characteristic of AI systems. The challenge for AIED systems, as in contrast to say an autonomous vehicle, it also understands its environment, it also makes decisions, but it doesn't have to collaborate with the driver in controlling the car. In fact, those systems, they want to take the control of driving entirely. In AIED systems, it's much more important for the system to collaborate with users, to collaborate with learners, so that learners have a stake in the learning process, and to collaborate with teachers, so that the system becomes a tool to help teachers and not is regarded as something something that replaces teachers. So I'm going to use an example. An area that we work on quite a bit at Alelo is intelligent systems that help people learn to speak a foreign language. And I bring this up because it illustrates all the different ways in which AI can play a role in an educational system. So learning to speak a language is very important. In fact, a common complaint of many people who say study a foreign language using conventional techniques is that they may know a lot of vocabulary, but they still aren't able to engage in a conversation. So one thing we're concerned with very much is how to help people using AI to develop communication skills so they can actually converse in a foreign language. And teachers will regard speaking as the most important language skill to learn, yet nevertheless, most classroom time is not spent in speaking activities. And in most classrooms, students don't have much opportunity to practice speaking. And basically, there are a few reasons for that. One is that it's hard to set up authentic situations in class that really involve speaking like you would in a real world setting. If the teacher needs to participate, to monitor what the students are saying and provide feedback, that's very difficult in a large class setting. So what happens in large classes is you tend to see people that are just sitting passively and listening. And students often, they don't get much opportunity to practice outside of class when a teacher is not available. Now, one approach which is emerging to address some of these concerns is online tutoring. And VIP Kid, which I mentioned, is one example of that. And it is very popular, but it's not scalable at all. It requires one teacher interacting with one student at a time. So can we use AI to help people to develop speaking skills in a more scalable fashion? So this is something that we've developed in working on for some time, and we've had good success. I'll bring this up as a case study of where AI can help in teaching people to be able to communicate more effectively, as well as the limitations of conventional instructional design approaches. So this is a case study. I recently interviewed a retired Army colonel who had been in Iraq. He had learned Arabic language and culture using one of our immersive games, Tactical Iraqi. He found it to be very useful. So that then later, when he became a battalion commander and was assigned to lead a battalion into Afghanistan, he had his entire battalion train with Alelo immersive games, tactical Pashto, tactical Dari. And the results were pretty dramatic. He attested to the fact that because his people were able to communicate so much more effectively, that it really contributed to peace and stability in that region, that insurgent attacks dropped from multiple events per day before they arrived to maybe 1 or 2 a month. So this was very exciting. This is very not unique. I've heard other stories like this from our products. But also, it was a little bit frustrating for us because we only learned that we didn't know about this until we talked to Colonel Wilson. We had no access to the data that was learned from the learners who were actually using this system. So, and this was potentially a lost opportunity. If we, at the time that this was being used, were able to monitor how the learners were using the system, we might have been able to make it more effective, identify problems that could be overcome for future versions. So this is really drove our move to the cloud and to a data-driven approach. So now fast forward to our current architecture called NSkill, which is a data-driven learning environment architecture. Like the earlier systems, it employs immersive environments where learners have to communicate on their own. They make their own decisions. They get formative assessments of how well they're doing. They get feedback. They get personalized learning on the areas where they need to improve. So because we have access to data now, we can do all those things more effectively and improve our AI algorithms more rapidly. And we can also provide analytics to developers, to learners, to teachers, to administrators, to make the whole learning process, as well as the development process, to become much more data-driven. And so we're really excited about this. We see that this has really transformative potential. Once you've got data in the system and are able to take advantage of it. As I said, the goal here is to create a system that collaborates with teachers. We talk about it as being an intelligent assistant for teachers. I'll play a little video here that provides a bit of a demo of how NSkill works, as well as describes what it tries to accomplish.
Skills artificial intelligence technology helps students improve their speaking skills and helps teachers teach more effectively. Think of it as a kind of teacher's aid.
Hi, welcome to the Metropolitan train station. Where are you traveling to?
I'm going to New York.
Great, I can help you plan your trip to New York. What day would you like to depart?
Skills immersive simulations are realistic conversations with intelligent animated characters. Students practice as much as they want in a safe environment. N-Skill gives students feedback and personalized instruction in the areas where they need to improve. It reports on student progress so teachers can provide the appropriate instruction and use classroom time more effectively. For more information about how artificial intelligence can help you teach more effectively, visit nskill.alelo.ai.
So just to drill in a little bit here in more depth, so you see the roles that AI plays in a system like this. So what we have here is fundamentally a natural language conversational system. So learners speak it into the microphone and the avatar on the screen responds. So it's called known as a task-based conversation. The learner has some task that they're trying to perform. That focuses the conversation. It also is helpful for the system because it can evaluate the learner's performance in part by how well they are accomplishing their particular task. So, and there are of course, lots of conversational systems that are available, but creating something that's designed to support learning has certain unique characteristics. One is that it has to be, the dialogue system has to be very robust and very tolerant of learner errors. For example, here is a example of an error on this screen here. Probably what the learner said is something like, "I would like to leave on 1st May." And so we use an off-the-shelf speech recognizer, which, because the word "may" was not pronounced in appropriate American English, was misrecognized. Also, the grammar here is not consistent with of American English. We in America say May 1st, not 1st May. But we need the system to be able to tolerate and even provide feedback on those errors. And so that means we need to understand what those errors are. And because we're collecting data from from learners using the system, that continually provides us more insight as to what types of errors learners make. So, role of AI in robust natural language dialogue. Then role of AI in providing feedback, providing an evaluation of the learner's performance, to then provide personalized instruction on the particular topics where the learner is having difficulty. So in this approach, basically to find out what learner needs to work on, you encourage them to try out a conversation. And then where they're having difficulty, provide them exercises on the areas where they're having trouble. So if they're having difficulty saying dates, then we can review date topics of how to say dates, like on May 1st instead of 1st May. Give students opportunity to then practice using those in simple conversational exchanges. And then when they're ready, go back and practice some more until they're able to successfully complete the conversation at a high degree of mastery. We're looking at the accuracy as well as the speed at which they can respond. Can they engage in a conversation that approximates real life conversation in English? So to support this, we developed N-Skill as an architecture that supports data-driven development that is collecting and leveraging data throughout, is also leveraging other cloud-based cognitive services. So in the N-Skill case, when you are talking to a character in N-Skill, it records your voice. That recording is saved on our end, on our server. That's then sent to a separate cognitive service, in this case from Microsoft, to transcribe and to interpret the utterance, and then N-Skill evaluates that response based on what it knows about common errors that learner makes, and provide evaluation of the learner's response. So data plays a very important role. It also plays a very important, increasingly important role for us in authoring. You know, in the old way of authoring instructional environments, the author would have to enumerate all the possible branches, all the alternatives. But we are increasingly training the models, the dialogue models, for example, in our system, based upon the data that we are collecting. So another advantage of this approach, by the way, is that by leveraging other cloud-based cognitive services, as those services improve in performance, N-Skill improves in performance as well. And so I see this as an important way forward for AIED systems to take advantage of the ongoing improvements in AI technologies. So we're constantly collecting recordings of what people say, transcribe them, analyze them. So how does the D3 process start here? So first of all, you need some way of bootstrapping or jump-starting the D3 process. How do you get started if you don't have access to data? Well, there are ways of getting access to data. There are there are publicly available corpora. For example, the Pittsburgh Science of Learning Data Shop has archives of data. The Linguistic Data Consortium has a corpora of data. What we do is we actually collect data from test subjects. Basically, for example, mechanical Turkers can play this role. Collecting initial data to start the process. I think looking ahead, there's an opportunity for people in the AI and education community to share and leverage other people's data. I think that's going to be increasingly important going forward, that there will be increasing demand for sharing learner data sets. And once that becomes the case, then this D3 approach, I think, will become much more commonplace. So then you continue through the process, you train the model, you deploy the update, then you collect more data, you look at what's going on with the new data, and then you update the models, and the cycle continues. And so in this process, you're able to continually improve the performance of the system, as well as extend its capabilities. So examples, in our case, we're collecting data from English language learners around the world. over 24 countries. And so we actually have a lot of insight into the different types of errors that language learners around the world make. But we really need that data to capture that insight. So for example, we started early on, we did a trial with a school in Thailand. And so, you know, we were curious, well, what kinds of mistakes in English do Thai speakers make? We didn't really know, but we knew that we soon enough would know once we started collecting data from those learners. The way we take advantage of that is basically we if you will, develop an error model that identifies common word recognition mistakes that can be indicative of certain types of pronunciation problems. Here, for example, are some of the word recognition variations from Thai speakers. And if you look at this, it kind of gives you a sense of what kinds of problems Thai speakers have. Some of these are actually learners around the world often have a similar problem. So for example, many Thai speakers have problems with short vowels in English. So instead of saying hobby, it sounds like they're saying hubby. You don't form plurals in Thai like you do in English. And so a lot of learners have problems in plural formation, at least at the beginner level. They also have problems with consonant clusters. So for example, a word like sports, Thai speakers have a lot of problems with that. There are a lot of consonants in that word. So they may end up saying just, some of those consonants. So given what the data is telling us, we can make our recognition system much more tolerant of these types of errors. What we find in practice is that as we get more data from more learners around the world, we end up with a model which is generally more robust regardless of what your native language is. So that's one of the things that we learned is we don't need to create a model, an error model specific to a certain native speaker, but that we can basically create a general model that is tolerant of a wide range of mistakes. Now, this approach only works, or rather it works best in task-based conversation. So part of what makes this work is that if the speech recognizer thinks it hears the word hubby, that's a perfectly valid English word, but it doesn't make any sense. It's unlikely to come up in the context of, say, ordering a train ticket. So therefore, or we're talking about your hobbies, which was the example here. So the more, basically, the knowledge of the task provides expectations that enable the system to properly interpret learner inputs in spite of errors. And interpreting inputs in spite of errors is really sort of the critical thing here. We want a system that can engage effectively in a conversation with learners, even if they're having a lot of problems with English. So I'll go through here a case study that goes into this a bit more detail. So I mentioned at the beginning the idea of a snapshot evaluation. Here is one of those evaluations that we conducted at the University of Novi Sad in Serbia. So these were intermediate level language learners. We had developed at this point a suite of learning modules for beginning English learners. We suspected that they might be useful for intermediate level learners as well, particularly those who need more practice speaking English. But we didn't know. But we thought this would be an opportunity to test that out. So we organized a study in collaboration with the English faculty there. There were 3 objectives. So one was to collect data from intermediate level English language learners, ELLs, so we could understand really what kinds of problems they exhibit, what we needed, how the system would need to be adapted to support intermediate level learners. We wanted to evaluate how beneficial the content we'd already developed was, and how beneficial the system, the approach was for intermediate level ELLs. So we hypothesized that the learners would consider it to be useful, fun, easy to use, and that these learners felt that they benefited from practicing with these simulations. So I should explain, this is using the Common European Framework of Reference, or CEFR scale for language proficiency, where basically A level is beginners, B level is intermediate, and C level is fully proficient. And then finally, we are testing a new version of the N-Skill dialogue in background on the same learner data. Basically, a new natural language understanding system that incorporated statistical text classification. So we thought that this would produce better results. We wanted to test it on learner data. So we thought, well, why don't we test it on the data that we're collecting as we're collecting it? And then we could compare one algorithm versus the other. So again, this is an example of how, using the D3 approach, you can accelerate innovation or accelerate updates, because you can be testing multiple versions simultaneously and then make decisions going forward as which is the best algorithm to use. So for this particular study, there were 80 students, nearly all from Serbia. They were all at an intermediate or CEFR-B level. So we tested both the release version as well as a new version of the dialogue system. I should say up to this point, we did not have any error data from Serbian speakers. We didn't know how well, I mean, we had trained it on Thai speakers, but it had not yet been trained on Serbian speakers per se. We had the learners practice until they could complete all of their objectives, and then we asked them to complete a Likert scale questionnaire evaluating N-Skill, as well as a Net Promoter Score, NPS. Those of you who are not familiar with Net Promoter Score, it's a common questionnaire item used in market research. Basically, it's asking, would you recommend this product or service to somebody else? And you evaluate them on how highly they recommend. So I'll go through different results. First of all, what we got in terms of data collection. This gave us a lot of insight in terms of sort of how learners at this level, what their level of proficiency is. They have good ability to construct English sentences, but they made many errors in grammar, usage, and pronunciation. So for example, in response to an avatar question, where are you traveling to? The response might be, are you going to travel to New York? Or might want to travel to New York City. In response to, what day would you like to depart? I want to depart at May 1st. I would like to leave at 1st May. I have to leave at 1st May. Lots of errors with English prepositions here and with word order, as you can see. And we see similar patterns with other speakers of Slavic languages, by the way. So basically, further support our contention that the dialogue system needs to be highly error tolerant. In terms of evaluation results, We got a net promoter score of 23. Basically, the possible score is from -100 to 100. So anything that's positive is good. A 50 is excellent. So I would score this as very good. Doing well, but room to improve. We did confirm that N-Skill English is a good way to practice speaking English. A lot of people felt, in fact, that the interactive conversations were amazing. To be able to practice with an AI avatar. Most students did feel that it helped their English speaking skill, although some disagreed. And one of the common reasons that people cited is they felt that the dialogue choices of the delivered dialogue system were too limited. So this actually confirmed our hypothesis going in is that we needed to incorporate statistical natural language understanding so that it would be more tolerant of a wider range of inputs. And in terms of actual performance of the dialogue system, basically, the key, if you will, the most important number that we track is what we call the success rate, how frequently the system is able to understand and respond to what the learner said in an appropriate way. And what we're seeing here is success rates in the 60 to 80% range, pretty good. We would really like to see these ranges in the 80 to 90% range. We never expected it to be perfect, just because, just as when a language learner is talking with a native speaker, there are going to be instances when the native speaker can't understand what the person says, or the person says something that's just unintelligible. But we want it to be high enough so that the learners are encouraged to practice. It varies a little bit from simulation to simulation, from scenario to scenario. Another statistic to watch here is the click-through rate, how frequently the learners basically selected from a menu instead of speaking for themselves. And we see that generally these are pretty low. For that train ticket example we were just talking about, click-through rate was relatively high. What we saw in the new version incorporating statistical natural language understanding, that it actually performed much better. By the way, you can understand all the errorful utterances that I showed you on the earlier slide. And if you were to get on and try it yourself, you would see actually it performs quite well now. So based upon that snapshot, we then released a new version with a new dialogue system, which incorporates the statistical natural language processing. And we're now getting ready for a new trial, this time with the University of Split in Croatia. Again, using intermediate level students. So here we can actually measure our improvement and then identify next steps in order to further improve going forward. So we envision a series of these snapshot evaluations as we continue to develop N-Skill's ability to support intermediate level language learners and support robust conversation and provide feedback. So that gives you sort of a view of how instructional design can be made data-driven. But I also see there's a lot of interesting potential for making teaching become data-driven, to make the data that we're collecting or making the analytics from that data available to teachers as well. We see some of those insights already. just looking from the data that we're collecting. So one thing that we look at is the total amount of time that different learners spend in practicing in these conversations. It tends to vary a lot. As we would expect, if a learner is performing well, they might not practice very much, or if they need a lot of help, then they should practice a lot, but hopefully they would improve. This particular data set here is from a university in Mexico. From our perspective, because we're collecting the data in the cloud, it doesn't really matter where the data is coming from. We also can analyze the data to track progress toward proficiency. So in the case of helping learners become proficient English speakers, we want to evaluate the accuracy of what they say, as well as how quickly they can respond. And there's often a trade-off between the two, that some learners, they'll speak very rapidly, make lots of mistakes. Other learners will speak very carefully and slowly, make fewer mistakes, but still, we want to see the learners improve over time. And so using this data, we can provide analytics back to teachers so that they can be tracking this. And they really are clamoring for this. I mean, they like this AI-based approach, but they really want insight in terms of how the learners are actually performing using the system. And we can see how that can potentially have a big impact on instruction. So looking ahead, I see a lot of potential for this D3 approach to accelerate the development of innovative AI-driven learning systems really to help support the development of really an ecosystem of data-driven development. So basically, we design our products so they can be integrated with other online learning products such as digital textbooks. We're very interested in sharing data with other developers, so we can see how our system is performing on their data and vice versa. And this can be a way for developers to get started. And ultimately, this could be a way of really sort of developing, supporting a global community of publishers and content developers that are using AI-driven tools. It can just be done much more rapidly using tools that are available. So this is what I think is the exciting potential going forward. So I will stop there. That's the end of my prepared presentation. And like I say, if you have any questions, type them into the chat window and be happy to respond to them. And while we're waiting, if any of you, you see my email address here. If any of you are interested in signing up and getting to try out Nskill yourself, we're happy to arrange that for you. All right, so question, beside time learners are spending in conversation, what about lexicon they use? This will be very valuable for teachers. So yeah, I agree completely. I think that there's a whole variety of analytics that can be generated from this data. Really, the question for us has been, well, where to start? So I mentioned response time or fluency as being, if you will, an initial high-level metric. But yes, providing deep metrics on grammatical, on vocabulary coverage can be generated from this data, as well as grammar mastery, what I envision going forward actually is incorporating a range of different types of analytical tools and recognizers that can be applied to the data and then provide further insights to teachers on how the students are performing. So a question, what type of features do you look into for training? I ask because you may be able to understand their pronunciation, but a native speaker may not. I think that we are mainly looking at this point at word level errors and grammar errors, and then we are working on basically use the recordings themselves to update the acoustic models to make them more tolerant of native speakers. I'm sorry, of learner errors. I think we've got a ways to go yet before we have a system that is good as a helpful native speaker in being able to understand and respond to learners. But I think we're within the range of what, if you will, an average native speaker on the street, how they might respond if they are interacting with a language learner and they don't have experience as a language teacher. But this is what we're doing now. I think there's much more that we can do to mine the data that we're collecting. Let's see. Question from Jack Mostow. Hi, Jack. So was the comparison you described before an A/B comparison of two versions of the live system or an offline evaluation of, so it was kind of in between, Jack. So it was an analysis on live data. It was two versions running of a live system, and then the other system that was running in background, but was withholding analyses, responses from the learner. So you could say that was offline in the sense that we looked at the results afterwards, but it was running on data as it was being collected live. And we find that approach to be one that we like using a lot, by the way. Of course, we could do offline later, but since we're collecting the data, we might as well analyze it. Now, let's see the other question, a part of here. Okay, so in that case, really, that evaluation was of the dialogue system itself. Now, I think what you're alluding to is that there are other types of evaluations that could be, yeah, all right, so let me clarify. We're looking at evaluating the dialogue system. Could it understand what the person said and then respond in an appropriate way, reflecting that understanding? There are other evaluations that would be useful to do, like, is it correctly able to detect and diagnose different errors as they occur in the speech input? And that's certainly something we would be interested in for future evaluation phases, but we're not part of that particular snapshot study that I showed to you. So now another question here, a question about the improvement in communication skills. How does the agent address the learner's errors so as to help learners correct these errors? So this is actually an issue that we have given quite a bit of thought about. And the way that we approach it is a combination of really, most of the feedback is after the conversation is done. The feedback to what extent it occurs live during the conversation is when the the avatar says, sorry, I didn't understand you. And so it requires the learner to rephrase. What we find is that if we provide too much corrective feedback in the context of the conversation, then it stops becoming a conversation and starts becoming a grammar drill. This is a constant tension that we face with these types of systems. So we want the learner to be aware when they're making a problem, but not necessarily provide corrective feedback on the spot. But that, of course, is a design choice. I would think that for beginner learners, it might be done a different way. And also, I should also emphasize that this is coupled with exercises that really focus on individual conversational turns, where you do get feedback after each individual conversational turn. So it's the combination that provides the overall feedback. So question, how might the DDD paradigm differ for domains other than language learning? So a couple things. We regard our dialogue systems as an instance of what we call decision simulations. Basically, it's a simulation of a real-world situation where a learner is called upon to make decisions on, decision point. I think that has a lot of potential. For example, we are applying that approach to training in the healthcare industry. I mean, you can think of lots of simulation-based learning where that kind of approach could be helpful. But in general, if you are incorporating machine learning in your pipeline, then you should be collecting data and utilizing data as soon as possible. And so some sort of D3 approach would be advantageous. Frankly, I'm very interested in hearing from people who are adopting similar approaches in other domains so that we can compare and contrast this and ultimately come up with a methodology that is of general utility for the development of these types of systems. Another question, have you thought about letting the agent repeat the learner's meaning using correct expressions? Yes, this is in our pipeline for future development. This is a phenomenon that is sometimes referred to as recasting in a language learning environment and in the language learning domain. And I'll actually, I'll back off a bit from what I said before about, that you don't want to give too much critical feedback in the context of a dialogue. Recasting is one way of doing it. So in other words, where the native speaker says, you meant to say, oh, you're traveling to New York, right? So that sort of thing happens sort of naturally without disrupting the conversation. That's a very useful approach, I think. So let's see, you said consider sharing corpora that occur in your system in order to leverage other services and more general research and didactics. Can I suggest you deposit some of these corpora in a fully open data bank, such as OLAC? I will definitely give that some that consideration. Sure, I think I'll take that under advisement. I think it'd be useful to do that. Can you imagine some algorithm to implement strategies that guide iteration in your cycle of data-driven development, such as collect? So I think to answer that question, we have to drill in a little bit further into what happens at each stage of the process. So for example, if as part of your machine learning methodology, you have a model selection phase, well, then that's going to have to be part of the of your overall development methodology. And so, where would that take place, and how do you evaluate that, those model selection choices? That would be one place where that works. So I think as we look more in terms of how machine learning and educational data mining approaches are applied in this context, we'll see more, if you will, we can elaborate this in more detail, and I think get at some of the points that you're alluding to here. And then just follow on, the most popular use is not necessarily the most intelligent one. Yeah, well, that's why this data-driven approach is so important. It really all boils down to listening to what the data is telling us. And if we're not getting the performance that we're looking for, or it's not really, system's not in a good alignment with the with actual learner behavior, then we need to rethink some aspects of the system design. So I think part of this also reflects sort of going into the design process, understanding, well, what are some of the design choices that require some empirical validation, and reflect them in the design as well. So we're running at the top of the hour here. I've got one more question, and I think we will break. How do you measure user engagement other than by time on system? So that is in the Likert scale questionnaires that we're currently utilizing, but certainly one can imagine other types of metrics that could be employed here. Some of them are already being employed in game-based learning and could be applied here as well. I think, for example, Roger Azeveto's group has been looking into some of these issues. So I think there's a lot of interesting possibilities. And at runtime, well, yeah, so I think those types of metrics could be utilized at runtime as well. So that from our perspective, I think that these are areas of future work to really close that loop in runtime, but I see a lot of potential there. So this has been great. Thank you for all your questions. And we will be recording this webinar. We are also doing another webinar tomorrow for people who missed it today. So if you know of people who might be interested, encourage them to join in. Also, to look forward to the next webinar in this series by Beverly Wolf from UMass, who will be talking about emotion and engagement and how to measure that in the context of learning. I think that will be very interesting talk. So signing off for now, thank you all for joining in.